Hi everyone, welcome back. This is IE 451 Engineering Economy, and today we are going to talk about Chapter 9. The title of the Chapter 9 is Other Analysis Techniques, and in Chapter 9, actually the Chapter 9 discusses about 4 different topics. But we will talk about only one of them, the future worth analysis. Just because we are run out of time, okay? And the future worth analysis is very much like present worth analysis. In present worth analysis, the comparison is made in terms of the equivalent present cost and benefits. However, the analysis is not necessarily made at the present time. And the analysis could be made at any point in time. And when an analysis is made based on some future point in time, it is called future worth analysis. Okay? And the 3 criteria for economic efficiency is summarized here in terms of future worth analysis. So if neither input nor output is fixed, then the criterion that you are going to use is to maximize net future worth, which is equal to the maximize the future worth of benefits minus future worth of cost. And if the fixed input is given, then our criterion would be to maximize future worth of benefits or other outputs. And if the fixed output, then we're going to minimize the future worth of cost or other inputs. And this table is very similar to the one for present worth analysis in Chapter 5, right? Okay, now let's solve some end of Chapter 9 problems. Corresponds to the future worth analysis. Okay. Okay, so we are required to compute the future worth for the following cash flow. So we are working on problem number 9-1. So if you look at the period by period change amount, it is $50. And in chapter, I believe, in chapter 4, we have learned about arithmetic gradient series, where the cash flow has a constant amount of change each period, which is this case, right? So this given cash flow can be broken into 2 components. One for a uniform annual series of $100 and another for an arithmetic gradient series of G equals 50. Is that right? So this given cash flow can be broken into these 2 components. 0, 1, 2, 3, 4, and 5. 0, 1, 2, 3, 4, and 5. Okay. So first, we're going to have a uniform series of $100. And the second one, for an arithmetic gradient series with g equals 50. So after you take out 100, what is left over? At the end of period 2, we have 50. At the end of period 3, 100. At the end of period 4, 150. At the end of period 5, we have 200, right? So this is the arithmetic gradient series of $50 over 5 periods. Okay. So let's first calculate the equivalent present sum. Let's say P prime and another equivalent present sum of money P double prime here. Okay. So once you obtain an equivalent present sum of money P prime plus P double prime at the end of period 0, what you need to do is convert the summation of P prime and P double prime to an equivalent future sum of money at the end of period 5, right? That's what you are going to do. So here P equals P prime plus P double prime. How do you get P prime? It's going to be 100 times P given A and 12% of interest rate over 5 periods plus P double prime, which is 50 times P given G, 12% over 5 periods. Okay? And what is this table value? P given A for 12%. So if you look at the page number 614 of our text, P given A over 5 period is 3.605. 3.605. And the P given G over 5 period is 6.397. So how much is this? It's going to be $680.35. Okay? Now, what you've got is the equivalent present sum of money at the end of period 0. So what you need to do is convert this amount of money to an equivalent future sum of money at the end of period 5. Okay? So F would be 680.35 times F given P, right? 12% over 5 periods. What is this table value? F given P over 5 period is 1.2 1.762. This is 1.762. Okay. As a result, we're going to have $1,198.78. So this is the answer. That is the future worth of this cash flow. Okay. Okay, then let's consider problem 9-3. For the following cash flow, compute the future worth. Let me redraw the cash flow diagram so that I can work on it. So here, starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. And at the end of period 1, there is a positive cash flow of 5. At the end of period 2, another positive cash flow of 10. At the end of period 3, we have 15. At the end of period 4, we have 20. At the end of period 5, we have 25. Since then, we have 30s until the end of period 11. Those are 30. Okay. And we are going to use interest rate of 10%. Okay. So for the first 5 periods, the period by period change amount is 5, right? So for the first 5 periods, period by period amount is $5. So 5 times P given G, 10%. And you got to be careful. You remember N period arithmetic gradient series has n-1 positive cash flow, right? Here, for the first 5 periods, the period by period change amount is $5, which means we can implement arithmetic gradient series here. But the n period arithmetic gradient series has n-1 positive cash flows. But here we have 1, 2, 3, 4, 5 positive cash flows. So what you need to do is set the equivalent present worth at the end of period -1. So let's set that is P prime. Then this is the arithmetic gradient series over how many periods? Over 6 periods. So you need to use 6 periods like this. So this will convert the first 5 cash flows to an equivalent present sum at the end of period -1. Is that right? Now we need to convert this to an equivalent future sum at the end of period 11. So we need to multiply f given p 10% over how many periods? From -1 to 11. So it's going to be 12. Okay? Now what is left over? We need to convert the last 6 cash flows to an equivalent future sum at the end of period 11. Is that right? So what you need to do is plus $30 F given A. 10% over how many periods? From 6 to 11 over 6 periods. So how much is that? Here, 10% P given G over 6 period is 9.684. This is the 9.684. And F given P over 12 periods is 3.138. 3.138. And what about this? F given A over 6 periods is 7.716. Okay? So how much do you get? So this is the equivalent future sum of money at the end of period 11. So in my previous calculation is $383.42. Okay, so that is the answer. Okay, then next, let's solve problem 9-8. A 20-year-old student decided to set aside $100 on his 21st birthday for investment. Each subsequent year through his 55th birthday, he plans to increase the investment on a $100 arithmetic gradient. He will not set aside additional money after his 55th birthday. If the student can achieve a 12% rate of return, what is the future worth of the investment on his 65th birthday. So I believe a lot of you will think about your future plan, your retirement plan. So this would be one of the good example for that. Okay, so let's draw the cash flow diagram given this problem description. This is the problem number 9-8. Okay. So the student set aside $100 on his 21st birthday for investment. So starting from 21st birthday until his 55th birthday. So we have 55 somewhere here. And he plans to increase the investment on a $100 arithmetic gradient. So here we have 100, and on his 22nd birthday it's going to be 200. On his 23rd birthday it's going to be 300, and so on. Here arithmetic gradient of $100. Okay, so the equivalent present sum of money at the end of period 20. Let's say this piece of 20. Then how do you compute piece of 20 at the end of 20th birthday? It's going to be 100 times P given A, 12%, and from 20 to 55, it's going to be 35 periods, and 100 times P given G, 12% over 35 periods, right? Because here the positive cash flow can be broken into two components, one for a uniform annual series of $100 and another for an arithmetic gradient series with $100, G equals $100. So that's why we have this, okay? So the P given A, 12% over 35 periods. That is 8.176. P given G, 12% over 35 periods is 62.605. Okay. Then how much is this? It's going to be $7,078.10. Okay. Now we need to convert this P20. We need to convert this piece of 20 to an equivalent future sum at the end of period 65, right? So we have somewhere down here 65. And let's say this is f sub 65, okay? So how would you get f sub 65? It's going to be $7,078.10 times f given p, 12% over how many periods? From 20 to 65. So it's going to be 45 periods, okay? Then what is this table value? 12% f given p over 45 periods is 163.988. 163.988. Okay? So how much is this? It's going to be $1,160,723. Okay? So this is the future worth of the investment on his 65th birthday. Okay? So this is the problem number 9-8. Well, let's solve problem 9-16 instead of 9-14. Okay, so Don is a 55 years old engineer. According to mortality tables, a male at age 55 has an average life expectancy of 21 more years. He has accumulated $48,500 toward his retirement. He is now adding $5,000 per year to his retirement fund. The fund earns 12% interest. He will retire when he can obtain an annual income from his retirement fund of $20,000, assuming he lives to age 76. He will make no provision for a retirement income after age 76. What is the youngest age at which he can retire? Okay, so as usual, let's draw the cash flow diagram first. So we are working on problem number 9-16. So he has $48,500 right now. Okay. And he's now adding $5,000 per year to his retirement. So he's adding $5,000. Per year to his retirement, and he is 55 years old, right? So this time his age is 55 years old, okay? And he lives to age 76. So let's say here he lives to age 76. Okay? So how many years you're going to live more? It's 21 years. Okay? 76 minus 55 is 21. So there are 21 years between these two ages, and he will retire when he can obtain an annual income from his retirement fund of $20,000. So somewhere from here, he will gonna get $20,000 from his retirement fund. Okay. So if I set x equals the years to continue working, then age to retire will be 55 plus x years. Is that correct? Age to retire will be 55 plus x. Okay? Which means that he will receive an annual income of $20,000 from his retirement fund. For how many years? He will receive an annual income of $20,000 from his retirement fund for total of 21 years minus x years. Okay? Total of 21 years minus x years. So here you're going to receive $20,000 of annual income from his retirement fund for these years, right? 21 years minus x years. So what you need is to find the value of x, where this cash flow let's say this cash flow is A, and this cash flow is B. So what you need to do is find the value of X, where this cash flow A is equal to this cash flow B. Okay? So we will use the amount of money he has at retirement. Amount at, let's say, retirement. Oh, sorry. Amount of money he has at retirement would be equal to the amount of money needed for his retirement. So that's going to be the present worth of, let's say, needed retirement fund. So there's the amount of money needed for his retirement. Okay? So we're going to use this formula. So it's going to be 48,500 times F given P, 12% over the next X years, right? Because X is the years to continue working. And then plus $5,000 times F given A, 12% over X periods. Okay? Summation of these two values should be equal to the amount of money needed for his retirement, which is this. Okay? So that's going to be 20,000 times P given A, 12% over how many periods? 21 minus X periods. Okay? Because here we're going to receive this annual funds of $20,000 from his retirement plan for 21 years minus X years, okay, which is this amount. Okay? So we need to solve this equation in order to obtain the value of X. Okay? So let's use the trial and error method. So for example, if X equals 10, then what value you're going to have? It's going to be 48,500. F given P, 12% over 10 years plus 5,000 times F given A, 12% over 10 years is equal to 20,000 times P given A, 12%. 21 minus 10 is equal to 11, right? And what is the table values for that? F given P over 10 periods is 3.106. F given A over 10 periods is 17.549. And is P given A. P given A over 11 periods is 5.938. So as a result, the left-hand side becomes $238,386. What about the right-hand side? The right-hand side is $118,760. So what can you say from this result? Because the amount of money he has at retirement is this much. But the amount of money needed for his retirement is only this much. So we can say that X can be less than 10 years. Okay? So X can be less than 10 years. Okay? So this time, let's use X equals 5. If X is equal to 5, then it's going to be 48,500 times F given P over 5 period. There is 1.762 plus 5,000 times F given A over 5 period. That is 6.353. And 20,000 times P given A, 21 minus 5, that is 16. So which is 6.974. So in that case, the left-hand side is $117,222. And the right-hand side becomes $139,480. So in this case, X should be greater than 5 years. Because the amount of money he has at retirement is a lot less than the amount of money needed for his retirement. Okay? So X should be greater than 5 years. So next, let's try X equals 6. If X equals 6, the left-hand side becomes F given P over 6 period, 1.974 plus 5,000 times F given A over 6 period, 8.115 equals 20,000. P given A, 21 minus 6 is 15. So 6.811. We need to check whether the left-hand side is equal to right-hand side. Okay? So in this case, left-hand side is $136,314, and the right-hand side will be $136,220. So this is the amount of money he has at the retirement, and this is the amount of money needed for his retirement. So I would say this is slightly larger than this. So the amount of money at retirement is slightly larger than the money needed for his retirement. So I think I can say the X would be 6. So the youngest age to retire is 55 years plus 6 years, okay, which means 61 years old. Okay, so that would be the final answer for problem 9-16. Okay. Okay. Then let's solve 9-22. IPS Corporation will upgrade its package labeling machinery. It cost $150,000 to buy the machinery and have it installed. Operation and maintenance costs, which are $1,500 per year for the first 3 years, increased by $500 per year for the machine's 10-year life. The machinery has a salvage value of 5% of its initial cost. Interest is 10%. What is the future worth of cost of the machinery? Okay, so let's draw the cash flow diagram first. So it can be purchased at $150,000, right? Right now, $150,000, and annual operation and maintenance cost would be $1,500 for the first 3 years. Okay. And then increase by $500 per year for the machine's 10-year life. So it's going to be 2,000 next year, 2,500 next year, 3,000, and so on. Okay. And 1, 2, 3, 4, 5, 6, up until 10. Okay. So it becomes 5,000. Okay. Sorry, the diagram, cash flow diagram, is not that accurate. Here, the initial purchase price of $150,000 would be a lot higher than this amount. Okay. And what else we need to consider? The service value. Okay. At the end of its useful life of 10 years. The 5% of its initial cost would be the service value. So 5%, 0.05 times 150,000. Okay, that would be the service value. So here, the positive cash flow can be broken into 3 components. So the present sum of $150,000 at the end of period 0 and a uniform series of $1,500 for the next 10 periods. And then arithmetic gradient series of $500. Okay, so it's going to be summation of we want to get the future worth at the end of period 10. That's going to be $150,000. You need to convert it to equivalent future sum at the end of period 10. So you need to multiply by F given P, 10% over 10 periods, right? And then the uniform series of $1,500 over 10 periods. So you need to convert it to equivalent future sum. So you need to multiply by F given A, 10% over 10 periods, right? And then what is left over? Here, after you take out $150,000 and $1,500 over 10 periods, what is left over? 3, 4, 5, 6, 10. At the end of period 5, you have 500. At the end of period 6, you have 1,000. At the end of period 7, you have 1,500, and so on, right? So obviously, this is the arithmetic gradient series with G equals 500, okay? And this 8 and 9, 10. So 2,000, 2,500, and sorry, let me redraw the diagram. Seven, 8, 9, and 10. So after you take out 150,000 and 1,500 over the next 10 periods, I'm sorry, at the end of period 4, we have 500. At the end of period 5, 1,000. At the end of period 6, 1,500. Then 2,000, 2,500, 3,000. And at the end of period 10, we have 3,500. Okay? So this is the arithmetic gradient series of 500 over how many periods? from 2 to 10 for 8 periods. Okay? So you need to add 500 P given G, 10% over 8 periods, right? From 2 to 10. So now you've got P sub 2, and you need to convert it to equivalent future sum. Let's say P sub 10, okay? At the end of period 10. So you need to multiply F given P 10% over 8 periods, okay? And then you need to consider the salvage value at the end of period 10. Because these are the future worth of the cost. So your salvage value would have negative value. Negative 0.05 times $150,000. Okay? So how much is this? Here, F given P over 10 periods. Oh, we are looking at 10% interest rate. So F given P over 10 periods is 2.594. F given A over 10 periods is 15.937. So 15.937. And P given G over a period is 16.029. And F given P over a period is 2.144. So how much do you have here? Okay, that's going to be $422,000. I'm sorry, $422,689. Okay, that is the future worth of cost of his machinery. And we just solved problem number 9-22. Okay, so with I-451 for this semester, we have learned about the basic theory and application of engineering economy. And here's what we've talked about during the first half of the semester, chapter 1, 2, 3, and 4. And during the second half of the semester, we have discussed about 4 major analysis techniques in engineering economic analysis. They are present worth analysis, annual cash flow analysis, internal rate of return analysis, and future worth analysis. Okay? Although the numerical calculations may look different, the decision is unaffected by the method selected. So when correctly applied, all of these evaluation methods will end up with the same result. However, certain problems may be more easily solved by one method. And we have practiced that with lots of end-of-chapter problems. Hopefully by this time, you have a good idea about the engineering economic analysis. So this is the end of IE 451 lecture. Hope to see you again in the near future. Okay. Thank you very much. Bye-bye.